So I've created a basic building structure which I can work from. I've also generated the initial data for this building. I've separated the floors into groups, and this will group both the walls and the floors themselves. More importantly, I've added attributes to these groups, as attributes are actually generally more useful than groups, as it's far easier to perform operations on them. So for these groups we have the exterior floors, and these will essentially be used to work on roof geometry, as well as parts of the geometry which can be seen from the outside of the building. While most of the exterior geometry will be roofs, it is also possible for us to have overhangs, mainly from balconies and walkways. We will need to make more information for these at some point, but we'll think about that later. I then have groups for the individual floors of the building. I also have the interior floors group, which contains all the floors within the building. This is the most fundamental information we'll need for any type of building. There is, however, one piece of information which we do not have for this building. This will be the corners of the buildings, which is also a very important group for us to have. There are numerous reasons to isolate corners. One of the main ones is specifying doors. You will either want a door specifically on a corner, or you will want to prevent doors from being on corners entirely. If we have doors on the corner of a building, this will actually change the structure of our geometry. For this, we'd usually collapse the geometry at the corner of the building, so we no longer have a triangle formed by the corner. Instead, we'll have a polygon which is at 45 degrees to each wall, and this will lead to the door facing out at an angle. We will also commonly have decoration on the corners of the buildings. We'll often have cladding or protection on the corners, or you'll have decorative corners, or in certain building styles, the corners will provide the actual structure to hold the building up. So we will want to have information for the corners. For this, I'll be working on primitives, and I want to loop over the primitives, so I'll need a for each primitive loop. I can look at the end of my loop, and we can see what kind of primitives we're looping over. So I'll set this to be a single pass, and we'll see that we're getting small rectangular pieces of each wall. We'll also see that the point order for these is reasonably random. This will give us very little control, and we will not be able to find the corners using this. So we're going to need to update this loop. I do not want to actually work on individual primitives. Instead, I want to work on the floors for the building. For the floors we have our groups, but these will not actually work for this. Instead, we're going to work with our attributes. This is one of the reasons attributes can be better than groups. We could probably do this with groups, but attributes are far easier to work with. I'll use this within the end node of the loop. Once again, the attribute that we're looking for is floor num. We could double check that this exists within the geometry spreadsheet. This will be used within the piece attribute field. I'll activate this field. I'll then set this with our floor number. And now instead of iterating over a single attribute, I'm iterating over each floor. The first thing that I'm going to do is fuse all of this geometry. Currently, these primitives are all separated, so we actually have far more geometry than we need, as we should have doubled points at each primitive. I can attach a null within the for loop. If we look at the points, we'll have rather messy floor numbers, and each of the points has overlapping numbers. Fusing our geometry will correct this problem. It should also give us more consistent primitive numbering. The next thing that I want is to make sure that this geometry has correct normals. So I'll add a normal node, and in this case I want point normals. We can activate the visualization on these normals. This is somewhere where the fuse node makes a big difference. If we attach the normals to our original geometry, we'll see that the normals at the corner are perpendicular to the walls, where with the fuse geometry, the corner point normals will point out at a 45-degree angle. This gives us more unique information for the corners, and will make them easier to isolate. I can now start isolating the geometry, and I'll do this with the group node. I'll be making a primitive group. I'll remove the base group. I'll then set my group using the include by edges options. Here I'll look for the minimum angle option, and if I raise this to about 20 degrees, I'll get a group of all of my corners. This is a reasonably easy way to isolate corners. Essentially, if the edge angles are beneath 180 degrees, you'll get our corners, and if it's above 180 degrees, you'll select everything. I'll set the name of the group node to be corners. I'll set the group name with $OS, so the group will be set off the node's name. And this will give us a group for all of the corners. Once again, I prefer attributes to groups, so we'll want to add an attribute for the corners. So I'll add an attribute wrangle node after the group node. This will be running over primitive attributes. I'll specify my items by group, and the group will be corners. I'll create an attribute which will be called corners. and I'll set this to be 1. We should now be able to check these attributes within the geometry spreadsheet. We should now have an attribute that applies specifically to the corners. I can now examine the result, so I'll turn off single pass. I can now set up visualizations for my attributes. The first attribute will be the floor number. Currently this is visualized as a marker, and this is because I wanted to see that the floor numbers are correct. But for visualization, turning this into a color will be easier. I'm then going to set this color with the ramped attribute, and this will give all my floors a unique color. Another option would be to use a random color, so I could set this to be random by attribute. I'll do the same for my corners. I'll activate the visualization in the information for the node, and I'll change the color type to be random from attribute, and we can now visualize our corners as a color. I now want to connect this updated geometry with the rest of our mesh. I will connect the section where I'm generating the floors to this part of the mesh. I'll connect the input of the for loop where I'm generating the interior floors to the output of the for loop where I'm calculating the corner groups. When I look at the end of this group, we'll see that we have an issue. Currently, I'm visualizing the corners, and each of the primitives of my floor currently has a different color. This means that these are having corner attributes added to them, and that these attributes are inappropriate. The first issue comes down to how I'm creating my attribute, in that currently this is a float attribute as this is a default attribute value. Here I actually want to specify that this is an integer attribute, so this should have a prefix of I. This does improve the visualization, but it doesn't solve the fundamental issue, and we'll see this in the merge node. Here we have a warning, and in the information we'll see that we have a mismatch of attributes, specifically the corner attribute, and this is something which we will have to fix. Before I do that, however, I will neaten this network a little bit. So here we have a couple of attribute clashes, and the first attribute clash which we'll deal with is not actually the attribute for the corners, it is instead the attribute for the normals. I can get an attribute wrangle node for this, and the attribute that we're going to be dealing with is a point normal. I'll rename this node to floor point normal. I am setting this with an attribute wrangle node because I know exactly what value I want for the normals, as all of these normals are going to have unit vectors in Y. This will be a vector attribute, and the normal vector has a name of n. I'll set this to be 0 in x, 1 in y, and 0 in z. I can then duplicate this node, and I'll do exactly the same thing for the interior floors. This should fix the normal attributes for now. Next I want to update the corner attributes. For this I'll need an attribute wrangle node as well, and this will be renamed to floor corners. Here I'll add the corner attribute, and this will be done with I at corners is equal to 0, and this should be a primitive attribute. There should now no longer be any clashes, and our floors and our normals should be cleaned up. All of our floors should now have normals which are facing upwards, and this should be correct as this will be the part which the player is interacting with, or more precisely, this should be the part that the player is walking on. Interaction here is a rather general term, as we may make the floors destructible at some point, in which case there's a possibility for both sides of the floor being interactable. This gives me my updated building. I have my floor groups. I have my groups for the interiors and the exterior floors, and all of these should now have correct point normals. And I also have my group for the corners. I do not necessarily, however, want this always to be merged. Essentially, this is not a building, this is a structure to create a building with, and we want to use this as the basis for manipulating data. So I'm going to add some nulls to each branch of this building. I will connect a null to the branch for the floors, and this will be called floors out. I'll do this for my wall branch as well, and this will be called walls out. I'll give these some colors so I can identify them. Floors will be brown, and I'll give the walls a green color. So this will give us our floors and our walls, which will give us our main building structure. I can now start working on the building, but I do also want to do some setup for tools which will make interaction for the HDA easier.